In this video, I'm going to show you how to use Tensor Tech's ADCS Testbed to conduct ADCS performance testing. Before we dive into that, you need to be aware of its limitations. First of all, it doesn't simulate the GNSS signal because it doesn't contain a GNSS simulator. Secondly, it doesn't have a star simulator, so it cannot simulate what your star tracker will observe in space. You can only test the attitude sensor with magnetometer and sun sensors, as well as the inertia measurement sensors. To use this platform, you will have to attach your ADCS on top of this platform. We recommend the user just put some satellite subsystems on the platform as the test objects instead of the entire spacecraft. This is because, in the later case, the ADCS on this platform will need to actuate a mass with much larger inertia than it should have to actuate in orbit. The suggested test object that should be installed on the platform, including the ADCS, onboard computer (OBC), electrical power subsystem (EPS), and a wireless communication module. The reason to put OBC on the platform is that it will send commands to the ADCS, as well as read its status for fault handling, which will ultimately impact the behavior of your ADCS. For the electrical power subsystem (EPS), its power quality will ultimately impact the behavior of the ADCS as well. As for the wireless communication module, it is for commanding your test setup and dumping out their outputs. The only condition that we suggest you to install the entire spacecraft on the platform is when you want to measure the mass properties of your spacecraft for setting your ADCS. Furthermore, the user needs to be aware of the disturbances that this platform will suffer. The first one is the gravity torque. The second one is the turbine torque. For the gravity torque, you have to refer to the center of mass measurement results while you are doing the mass properties measurements of the testing platform. By knowing the position of the center of mass of this platform, as well as the inclination angle for that certain moment, you can calculate what gravity torque this platform is suffering right now. It could be a major source of disturbance. It usually occurs for the X and Y axis mostly, and there's turbine torque that exists in 3 axes. Back to the ADCS testing, the mass properties for the entire platform as well as the testbed objects have to be measured in the first place. This is because it is essential for you to do the settings for your ADCS just for this performance test. So after you put everything on top of this platform, then you can activate your ADCS. Tensor Tech's DynaSense, an attitude and heading reference system that is installed on top of this platform, will estimate the attitude for the user. You can get access to its determined data through a Skippy command interface that is provided on our manual, and you can use it as a reference for your attitude control. It is suggested that for every ADCS modes, the user needs to conduct the functional test on the ADCS testbed to verify and validate that the integrated ADCS can reach to the expected performance in space. After the experiment is done and you finish all the mass properties you want to measure, we should terminate the testbed following the procedures below. First, the user should rotate the control lever to let the mechanical support of the spherical air bearing to a higher position. The testing platform will then be touched by the mechanical support. Secondly, turn off the pressurized air source. Then you are allowed to remove your testing articles. So that's an introduction to Tensor Tech's ADCS Testbed. I hope you enjoy the operation of our products. Thank you for your listening.